today to work some, two more problems from 1.2, and we will get started. Okay, so here is problem number 5 in 1.2. Remember, I did not post any problems from 1.1. I don't have a video for 1.1 because it was mainly all terminology. So this is the second video for 1.2. So 1.2 focuses on frequency distributions, and here you have a table or a full frequency distribution, and we're asked to construct or expand it. So right here, we've got the classes given. Okay, the classes, it says use the frequency distribution shown below to construct an expanded frequency distribution. So we're talking about temperatures, high temperatures. So the classes are broken or separated according to a range of temperatures. So the first class is 15 to 25. Then you've got 26 to 36, 37 to 47, 48 to 58, 59 to 69, 70 to 80, 81 to 91. Okay, and then you've got the frequency for each of those classes. Remember, the frequency is just how many data values actually belong to that class. So if we actually had the data set, which we don't here on this problem, but if we actually had the data set, we would be looking or determining that 17 of them belong to class 1, 45 belong to class 2, and so on. Okay? So what we're going to be finding to finish up this table is the midpoint, the relative frequency, and then the cumulative frequency. So let's talk about each one. So the midpoint is just the middle value of each class. And we did see how we found the midpoint in the previous video. That is where you take the lower limit of the class plus the upper limit of the class, you add them together, and then you divide by 2. So the midpoint is the average of the two, basically. Lower plus upper divided by 2. So 15 plus 25, and then divided by 2. So that would be 20. And because of the way this class is actually expanded or ranges, it might have been easy for you to find that value without using the midpoint formula, but they won't always be that easy, so I do recommend that you use it. But it might have been easy for you to determine that 20 is the middle value between 15 and 25. Okay? So then we continue on. We got 26 plus 36 divided by 2, so that's 31. 31 is the middle value there between 26 and 36. Again, because 31 is exactly 5 units above 26, and it's 5 units below 36. Then you got 37 plus 47, divide that by 2, you got 42. Then you've got 48 plus 58 divided by 2, that's 53. And you may have already determined that the lower limits are all increasing by 11, okay, which is the same thing for the upper limits as well. They're all increasing by 11. So that means the midpoints would also increase by 11. So 20 plus 11, that's where you get 31. 31 plus 11 is how we get 42. So you could find the rest doing that, but the midpoint formula does work as well. So either way, however you want to do that. So we got 64. Let's see. Then we got the 70 plus 80. So that should be 75. And then lastly, 81 plus 91 divided by 2, we got 86. Okay, so they're your midpoints. Now, relative frequency. So here in this table provided, we've got the frequencies. Well, relative frequency is a proportion. So it's a amount or how much of the total data set belongs to a particular class. So relative frequency is the proportion of data values that belong to a class. So to get the relative frequency, then you would take first, you would have to take all the frequencies and add them together to get the total. So first, in order to get the relative frequency, first find total frequency. And that is where we add up all of those frequencies. We got to get the total sum. So 17, let me clear that. 17 plus 45 plus 66, 67, 81, 66, 23. So we get 365 is our total. Okay. Now that means for that first class, it has the frequency of 17. So its relative frequency would be 17 out of 365. Now I'm going to put 17 out of 365 here on this paper, but when you enter your answer, you're just going to enter the decimal value. And it says round to the nearest hundredth. That is 2 decimal places. Okay, that means 2 decimals. So 17 divided by 365 is 0.0465. So if we're rounding to 2 decimals, that would be 0.05. Okay. The next one has a frequency of 45. So 45 out of 365, that gives us 0.12328. And again, we're only going 2 decimals, so that's just going to be 0.12. So that's 45 out of 365. So 0.12, rounding to two decimals. The next one, 66 out of 365. That's 0.1808. So 0.18, 66 out of 365, 0.18. Then we got 67 out of 365. That's 0.1835. So again, 0.18 again, if we're only going 2 decimals. 81 out of 365, that's 0.22. 66 again, that's 0.18. And then 23. That one is 0.06. Okay, so again, you would be showing your answer to 2 decimal places, 2 places after that decimal, 2 decimal places. Okay, you won't show the fraction. I only showed you the fraction so that you would have an understanding of where these numbers came from. Okay, when you go back and look. All right, now cumulative frequency, this is the sum of the frequencies of a class and all classes before it. Okay, so cumulative, think sum, think like as you go through the list, you're adding. All right, so cumulative frequency, again, is the sum of the class frequencies, sum of the frequencies of a class and all classes before it. So that first class, there is no class before it, so its cumulative frequency will match its frequency. So that first class has a cumulative frequency of just 17. There's nothing before it. Okay. The second class, it has a frequency of 45, so you will then add that to the frequency before it. 45 and 17. So 17 and 45 together gives us 62. Now I'm going to put right here where that came from. That was 17 plus the 45. So that you'll kind of know, okay? The third class has a frequency of 66. So you will take that 66 and you will add to it all frequencies before it, both of the ones before it. So 66 plus 45 plus 17. That gives us 128. So that was 66, the 45, and the 17. Okay, just so you know where that came from. I may run out of room trying to squeeze that on there, but Now we'll take the next class. It has a frequency of 67. So we would take that 67 and everything before it. So the 66, the 45, and the 17 all get added to 67. Well, we already said that was 128. So let's just say 67 plus the 128, which was those three together. That gives us 195. So that is 67, 66, 45, and 17 all added up. Okay. Now I may not write the last few here because I'm running out of space. I'm just going to put the number, put the cumulative value. Okay, since we have an understanding of what we're doing. So that next class, we take the 64. Did I miss one? I think I did. Hold on. So I was supposed to say 128. I think I added 67 again, and I'm not. Let me slow down. Let me go back here, because I may have made a mistake here. So 42. Oh, I'm looking at midpoints. I'm sorry. I'm over here. Whew, okay. So I'm good. I'm good. I was making a mistake there, looking at the wrong column. Here's the column I'm using. Okay, yeah, it can kind of get all, fuzzy when you're looking at all these different numbers in these different columns. So stay with the right column. So here we are right here. So frequency to find the cumulative frequency. All right, so now we're at 81, and we'll take everything before it and add to the 81. So basically we're taking the 195 that we already had, and now we're going to add 81 to that. So 195 plus 81, that gives us 276. Then now we're on the next class. We take the 66 and we add everything before it. So 66, 81, 67, 66, 45, and 17. Well, we already know that was 276. So we take 276 and we add 66 to it. That gives us 342. And then remember what our total number of values were. Okay, so keep that in mind. Now we take this last frequency and we add everything that we have before that to it. So everything before, all the frequencies before 23 added to give us 342. So 342 plus 23, that gives us 365. And that's how you'll know that you have the correct cumulative frequencies, because that last cumulative frequency should be equal to the total number of data values that you have. So I have a total of 360 data values in my data set. Even though I don't have the actual data set, these frequencies represent how many data values we have. So when I add up these frequencies, I'm representing, or I'm using that to represent the total number of data values. Okay? All right, so that's number 5. Hopefully that makes sense to you. Okay? Now, of course, you got lecture videos. I'm just kind of doing this too to help you even understanding a bit more. Okay? Okay. And here's the last one that I wanted to work from 1.2. This is number 8. So on this problem, we actually have to construct the entire frequency distribution. Okay, on the previous problem, we had the classes given, and we had the frequencies given. Okay, this particular problem, all we have is the data set. Okay, and we are to find the classes. We're told how many classes we're using. And then for each class, we'll find the frequency, the midpoint, the relative frequency, and the cumulative frequency. So the main thing with this problem is going to be ensuring that we set up our classes correctly. I cannot explain to you how important that is, okay? Because if your classes are wrong, that's going to affect every answer after that. Okay, because if your classes are wrong, the frequency would be wrong, the midpoint would be wrong, the relative, everything would be wrong. Okay, so it's imperative that you set the classes up correctly. Okay, so first thing we have to find in order to set up our classes, we're going to have 5 of them, and you'll notice that there's 1, 2, 3, 4, 5, a space for 5. The lower limit to the upper limit. Okay, so you got the little dash separating. This here to the left will be the lower limit to the upper. Okay. Also, when I printed this, it shows me all the blanks, or shows me where all my answers will go. When you're working this and plugging in your answers in the system on the computer, It will make you type in your answers across, okay? So it'll make you complete one full class first before you go to the next one and the next one, okay? Now, even though it makes you do it in that order, it makes you enter your answers in that order on the computer, I recommend you write down the classes, because in order to set the classes up correctly, you're going to find all the lower limits at one time, and then you're going to find all the upper limits at one time. So if you already have those written on paper, then entering them into the computer will be a breeze, okay? It will make life more simple if you use some paper and go ahead and find all the classes. So that's what I'm going to be doing. Okay, so the first thing I have to do in order to get the classes is I have to find the class width. This is step number 1. Okay, get the class width. To get the class width, we take the max data entry, subtract from it the minimum data entry, and we divide by the number of classes that we're told to use. Okay, so what is our max entry? So here's our data set. Looking at the data set, the maximum value in the data set looks to be 39. Okay, the minimum data value appears to be 0. And then we're told to use 5 classes. You will always be told how many classes to use. Okay, so 39 minus 0, just 39. So 39 divided by 5, we get 7.8. So that means our class width rounds up to 8. Okay, we have a class width of 8. All right. Okay, now let's get the classes. Your first class always starts with the minimum value. So let me put just like a little 1 here, 2, 3, 4, 5. And like I said, even if you can't print the problem, get you some paper and jot down the table, okay? The classes, frequency, jot down what you're going to be actually entering into the computer, okay? So our first class will always begin with the minimum data entry. And we should already know what it is because we had to use it to get the class width. So your first class will start with the smallest data value, the minimum data entry, and that would be 0. Okay? From there, I'm going to find all of the remaining lower limits. So the first class lower limit is the smallest data value. Okay, so that's basically kind of what you're doing second. You're putting in that first class lower limit. After that, you're going to then find the remaining lower limits by adding the class width to every preceding lower limit. Then find the remaining lower limits by adding the class width to each preceding lower limit. And you're going to do the same thing for the upper limits. So I may not write all that, but you're going to do the exact same thing for the upper limits as well. You're going to find that starting value, and then you'll add the class width every time for it. So if we add the class width to 0, 0 plus 8, that is 8. 8 plus 8, that's 16. 16 plus 8 is 24. And then 24 plus 8 is 32. Okay? So we took that first lower limit and we added the class width to get the next one. And then we added the class width again to get the third one. We added the class width to the third one to get the fourth one. And we added the class width to the fourth one to get the fifth one. And now we have all of the lower limits. These are the lower limits. So So you find all of them first. That's why it's important that you jot it down on paper, okay? Because you need to find all of the lower limits first and then find all of the upper limits. So even though when you're working it on the computer, it's not going to actually show you any of the second, third, or fourth, fifth rows. It's going to make you finish this row completely before you go to the next one and the next one. On paper, you can go ahead and jot down what you want. Go ahead and jot down those lower limits so you already have them all. Okay? Now let's get the upper limits. So we have to have a starting point for the upper limits. We don't have a value necessarily in the data set that we have to use for the first upper limit. The way that we get that first upper limit is we look at where the second class starts. So the second class starts at 8. It has a lower limit of 8. Remember, these classes consecutively follow each other. So if class number 2 begins at 8, class number 1 had to end right before that at 7. They're supposed to follow each other. They're not supposed to overlap, but they're supposed to consecutively follow each other. So if class 1 ranges from 0 to 7, class 2 starts at 8 and goes to 15. Think about it. Class 3 begins at 16, so class 2 had to end right before that at 15. Okay? Or you could have just said 7 plus 8 and got 15. Okay? And you can say 15 plus 8, and you'll get 23. And then 23 plus 8, and you'll get 31. And then finally 31 plus 8, you'll get 39. So that very last upper class happened to be an entry in the data set for this problem, but it didn't have to be. Okay, it did not have to be. Remember, sometimes your classes can be a little big, just so long as it ensures that every data entry will fit into a class. This one is actually spot on. It's perfect because our largest entry is 39 and it ended with 39, but that will not always be the case. Okay, understand that that will not always be the case. So now you got all your upper limits, and now you're ready to complete the table. That's the hardest part, honestly. The rest of this is kind of tedious. We've looked at how to find the midpoint, the relative frequency, and the cumulative frequency already. Getting the frequency, we haven't done that yet. So getting the frequency just means looking at the data set, counting how many data values belong to each class. So you have to be really careful here, but it's really just a little tedious checking them off or looking through and counting, okay? So basically for that first class, I'm looking for all numbers anywhere from 0 to 7. And I'm going to count how many I have. So I'm going to go down the columns here. 0 to 7. So I don't have any here. I got 1. That number right there fits that class. So I've got 1 here, 2, 3, and that's it there. I tell you, I'm going to circle them. I got 1, 2, 3, 4. I've got 4 values that belong to that class. So my frequency for that first class is 4. Frequency is just the number of data values that belong to a class. Okay? So there are 4 that belong to that class. Now, let's go ahead and go on across here since we're looking at this on the computer. Remember, this is the main thing you need to write down, but from here you can go kind of across on the computer. But do write your classes down, write those down, okay? And enter them as you need to. So the midpoint now, we're looking for the middle value between 0 and 7, okay? So let's see. So we say 0 plus 7 divided by 2, we get 3.5. Never round the midpoint. Keep that 0.5. If it ends up being 0.5, you keep it. If it ends up being a whole number, then it's a whole number. But you never round the midpoint. Never round the midpoint. Okay? The relative frequency, well, that is simply of the whole data set, counting how many belong to each individual class. So we need to know how many data entries we actually have, and of that total, how many belong to each class. So there are 1, 2, 3, 4, 5 columns of 1, 2, 3, 4 data values. So there are 20 total. 20 data values. 20 total. So the relative frequency for that first class would be 4 out of 20. Now I'm going to put 4 out of 20 here, but when you enter the answer in, it should want the decimal. It should want the decimal. And it didn't print on here, but I am positive that it's going to want the decimal. And that should actually be a finite decimal, so you shouldn't even have to round this. Yeah, it's just 0.2. It's not a repeated decimal or an irrational number. It's just 0.2. So it's a finite decimal. You just put 0.2. Okay? Next class, moving on. We're looking for any numbers that lie anywhere between 8 and 15. And this does include 8 and 15. Okay? I'm going to put like a slash through these. 8 through 15. So I don't have any there. 12 is 1. 9 is 1. 15 is 1. 14 is 1, and 16 is the next class. So those ones that I have the slash through, I've got 1, 2, 3, 4. So there are 4 data values for that class as well. Okay? So that has a frequency, that second class has a frequency of 4. All right, the midpoint would be 8 plus 15 divided by 2. So that's 11.5. And then the relative frequency is 4 out of 20. So 0.2 again. Oh, and I forgot cumulative frequency. Let me do that. All right. So remember, cumulative frequency is the sum of a class's frequency and all frequencies before it. That first one has nothing before it, so its cumulative frequency is going to be the same as its original frequency, 4. Class number 2 had a frequency of 4, and then you're going to add the frequency before it. So 4 and 4, that gives us 8. Okay. All right. Third class, 16 to 23. So all numbers that lie anywhere from 16 to 23. I am going to put an X through these. I want them to stand out to me. I already got circles and a line, so I'm going to put an X. 16 to 23. So 18, 16 to 23, nothing there, nothing there. No, 16 and 22 works. So I've got 1, 2, 3 data entries that belong to class number 3. Okay. The midpoint would just be 8 more than the previous one, or you can find it by calculating 16 plus 23 divided by 2. 19 and a half. Remember, we do not round the midpoint. Okay. The relative frequency, it will be 3 out of 20. And that is 0.15. And again, we're not rounding. It's a finite decimal, so I'm keeping the 0.15. And then the cumulative frequency would be the 3 added to the 8 that we had before it. So 3 plus 4 plus 4, we get 11. Okay. All right. Now we're looking at numbers anywhere from 24 to 31. So all data entries that fall anywhere between 24 and 31. I'll put a box around these. 24 to 31. Nothing here. 27 works in the second column. Nothing in the third column. 27 works in the fourth column. And so does 28. And 29 in the fifth column. So I've got 1, 2, 3, 4 boxes. So this class has a frequency of 4 as well. Okay. The midpoint would be 24 plus 31. And then divide that by 2, and we get 27.5. The relative frequency, there were 4 data entries that belong to this class, so 4 out of 20 again. That's 0.2. And then the cumulative frequency, we're going to take the 11 that we had before, because we had 4, 4, and 7. I'm sorry, 4, 4, and 3, so that's 11. And then we're going to add 4 again to that. And now we're going to add an additional 4. So 11 plus 4, that gives us 15. Okay? So we've got one class left, and this last class ranges from 32 to 39. That should be every number that is not marked off, not circled, not boxed off, or doesn't have a slash through it. The rest of the numbers that have no markings belong to the last class. So that is 1, 2, 3, 4, 5 of them. So class number 5 has a frequency of 5. And you can verify that these frequencies are correct because they are together supposed to add up to give you 20. Okay, remember when we find the frequency, we're just partitioning the data values into a class. So you should not have any more than the total number of data values that you have. So 4, 4, 3, 4, and 5 should add to give us 20. Okay. Now, the midpoint is the middle value of that last class, so 32 plus 39 divided by 2. That gives us 35.5. And then our relative frequency is 5 out of 20, which should be maybe 0.4. Let's see. 0.25 maybe? Let's see. Yeah, 0.25. 5 out of 20, 0.25. And then lastly, the cumulative frequency for this last class would be 5 plus all the frequencies before it. So 5 plus 4 plus 3 plus 4 plus 4. And that gives us 20. That last cumulative frequency should match the 20 total number of data values that you had. Okay? So we just completed a frequency distribution. Now, there are 2 questions here. It says the class with the greatest frequency is from blank to blank. Well, that would be that last class. It has a frequency of 5, and it ranges from 32 to 39. And in the class with the least frequency, the frequency of 3 is the smallest frequency, and that class is 16 to 23. So the class with the least frequency is 16 to 23. Okay? And that is 1.2. Last problem there. All right. Look for me soon in Module 2.